next type of reaction is called the single displacement reaction. Now the key word here is single. When you displace something, you kick it out. Let's take this example. You see a couple walking down the hallway, deeply in love, obviously, and I can make blue eyes at each other. But there's this guy lurking on the side going, she should not be with him. I'm a better guy than that guy. He picks his nose. Oh my gosh, what a dork. She needs to be with me. So his goal in life is to displace him and make that guy, the girlfriend of, or the boyfriend of the girl, make him no longer a thing with her, no longer the boyfriend, and then he steps in and creates a new compound, a new couple, leaving him on the outside. And that's exactly what the ions are doing, or the atoms are doing, is that this won't take place for ionic compounds, that this is going to occur in some cases not, but usually it's ionic. And one ion, say it's a positive ion, is going to kick out a positive ion of a compound and kick that one out, and that will become the new compound with the negative ion that's left over. Or a negative ion will come along and kick out a negative ion in the compound and then link up with the positive ion that was originally part of the compound, first compound. That's what's happening here. Okay? So, let's take an example here. Let's take barium sulfate. And now, this isn't what we call an aqueous solution, so I need to explain what that means. I know many of you take Spanish. What does the word agua mean? Water, right? It comes from the Latin word aqua. Spanish is what we call a Romance language. It comes from the Romans, which spoke Latin. I took 3 years of Latin in high school. Aqua was the basis of water for that, and then all the other languages have their variations on aqua. Spanish, of course, is aqua. And so this means dissolved in water. But the water is not part of the reaction. It's just the medium in which the reaction is taking place. You're going to add to that calcium metal. Now the question here is, I'm sorry, not calcium, let me make that sodium. The question is, what happens when this occurs? Well, in order to do this, we need to have charges. So you need your periodic chart, and you need your polyatomic ion chart. If you're working in class, I'll have some polyatomic ions on the table by the loud air conditioner or heater. So you can use that. But you do need to identify all 3 ions. The best way to do it is by putting them above the ions in the molecule and by itself. So we start off with barium. Now barium is a metal in group 2A right there. So what's the charge of barium going to be? Positive 2. Put a plus or positive right there. SO4 is a polyatomic ion. If you got a positive ion here, then everything else is negative. So SO4 is a negative ion. Find SO4 in the polyatomic ion chart, and you'll find that its charge is 2 negative, which makes sense because they have to add it to 0. Now sodium, when it reacts, will become an ion of what charge? Well, find sodium on the periodic chart. It's in column 1A. So it's going to have a charge of positive 1. Now, what that tells you is that the sodium is going to kick out the positive ion barium. So the Na is going to be with the SO4. And that's going to leave poor barium all by him or herself. Okay? Now, First thing we need to do after this, first we do create the displacement. And after finding the charges. The ions. Okay? So you gotta find the charge of the ions, and then you create the displacement. The displacement again is the sodium displacing the barium is down by itself, and the sodium and the SO4 are hooked up. Right? The next thing we need to do is make the compound formulas correct. How do we do that? Make the charges add up to 0. Okay? So the question is, do they add up to 0? Well, let's go ahead and put the charges for these. We don't need to put it there because it's not creating a compound anymore. But take the plus charge for the sodium right here, take the 2 negative charges of sulfate there, and we ask ourselves, does that create a charge of 0 when you add them together? And of course the answer is no. So we got to do something here. In order to make this add up to 0, we got to have twice as many sodiums. So we're going to take this positive 1 and multiply by 2. And that gives it a positive 2 charge. So that means then that we got to put a subscript 2 right there. That is now the correct formula for sodium sulfate. Next, we have to get the phases, find the phases. Okay? Now when this happens, this is what we're going to do today. We may end up doing it slightly different the next time we have a lesson here because we're going to see something occur. But for right now, this is what we're going to do. When you create a new compound, it's going to stay dissolved in water. So we're going to put the phase for this as aqueous. So the phase of the compound is aqueous. The phase of the new compound okay? Now we go back over here, we got the aqueous there. The barium, we just go look at it on that list of ions we had. Is barium a liquid? Nope. Is barium a gas? Nope. That means it has to be a solid. Okay, so now I'm going to rewrite this below this, and now the last thing I need to do is to balance the equation. Show you a little trick with this that will make it pretty easy. But what we have now, this is what we return. Barium sulfate aqueous plus Na solid yields Na2SO4 aqueous plus barium. Now, draw the line. Well, this is solid. We have barium here. Barium has a charge, only has one right there, sorry, with no charges. Rather than split up the sulfur and the oxygen into two different elements here, we're going to pretend like a polyatomic ion is an element. So I'm going to write SO4 right here. And we have one of those. sodium, we have one of those. Come over here, we have barium listed first, we got one over there, sulfate is next, we got one right here, and then sodium, we have two. And I think you can see what needs to be done to balance this equation. Yep, just put a 2 in front of that sodium, and now you have your balanced equation for the single displacement of barium sulfate with sodium. Okay? Now that's what happens when a positive replaces a positive. Now let's take a look and see what happens when a negative replaces a negative.